Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, welcome you all to this session on the phenols. Now, first we will discuss about what are the learning outcomes of this session. After this session, students will be able to define phenol, means what is the meaning of phenol, what is the structure of phenol, give various examples of phenols and its derivatives, explain effect of substituent on the acidity of the phenol. So these are the various learning outcomes of this session. So student should be able to explain these things when you complete this particular module. Now let's begin with what is the meaning of phenol. Now phenol is a chemical class of compound having hydroxyl group directly attached to the aromatic system. Now here it is important that hydroxyl group is attached to the aromatic system. They are also known as carbolic acid. So carbolic acid is a synonym for the phenol. Remember, there is a difference between the carbolic acid and the carboxylic acid. Carboxylic acid is consisting of C double bond OOH as a functional group, while carbolic acid, that is the phenol, is consisting of a hydroxyl group, but this hydroxyl group is attached to the aromatic system. Now, depending upon the number of phenol groups, that is the hydroxyl groups that are present, they are classified as simple phenols as well as the polyphenols. Means here, as you see the structure of the phenol, where only one hydroxyl group is there, so this is known as the simple phenol. Means simple phenols are nothing but the phenols in which only one hydroxyl group is present, while the polyphenols means what? The polyphenols are those phenols in which the number of hydroxyl groups are more as compared to the one. Now also another thing that you should understood about the phenol is, here you know that the hydroxyl group is present in the phenol. Now we know a similar compound in which hydroxyl group is present that are known as the alcohols. So phenol is not categorized under the alcohol. There is a difference between the phenols and the alcohol. Though the hydroxyl group is same, the behavior of these hydroxyl groups is different, because in alcohols generally the whatever hydroxyl group is present, that hydroxyl group is attached to the saturated system, while here in this case the phenol, the hydroxyl group, as we know, that is attached to the aromatic system. So when the phenol, that is the hydroxyl group, is attached to the aromatic system, in that case only we can consider it as a phenol. Otherwise that particular compound is considered as a alcohol. Also there is a difference between the nature of these compounds, that is the alcohol as well as the phenol. Phenols are phenols are acidic in nature, while the alcohols are neutral in nature. Phenols are about 1 million times acidic as compared to the alcohols, but still they are regarded as a weak acidic compounds as compared to the carboxylic acid. So that is the basic difference between the phenol and alcohol, where alcohols are consisting of the hydroxyl group which is having a neutral nature and which is attached to the saturated system, while in case of the phenol, the whatever the alcoholic group is there, that is the hydroxyl group, that hydroxyl group is attached to the aromatic system. So hydroxyl group in the phenol is known as the phenolic hydroxyl group, and the hydroxyl group that is present in the alcohol, that is known as the alcoholic functional group. After this we will see various examples of the phenol. Now here you can look at the different phenolic examples that I have given. Now these are the examples of the polyphenols. Already we have seen the example of the simple phenol where only one hydroxyl group is there. Example of simple phenol is our normal phenol. Now the first example of your polyphenol compound is catechol. Now here you can see here two hydroxyl groups are there which are regarded as a phenolic hydroxyl group. These two hydroxyl groups are present at ortho position to each other. That's why this is known as the catechol, and chemically this is known as the benzene 1,2-diol. So this is the common name for this particular compound, and this is the chemical name for this compound, where when hydroxyl groups that are present at the ortho position to each other. Now if we consider this as a substituent, then this position is ortho and this position is ortho. And if we consider this as a substituent, then this position is ortho to this substituent and this position is also ortho to this substituent. That's why we are considering at these groups that are present at the ortho to each other. Then if these two hydroxyl groups that are present at the 1,3 position, that is known as the resorcinol, and chemically it is known as benzene 1,3-diol. Similarly, when hydroxyl groups that are present at the 1,4 position, they are known as the hydroquinone. Means here what we are going to do, just we are changing the position of the hydroxyl group from ortho position to meta position and to the para position. So we are getting CRH, that is the catechol, resorcinol and hydroquinone, where it is known as the benzene 1,4-diol. Similarly, we can write the structure of polyphenol in which there is a presence of the 3 hydroxyl groups. For example, if these hydroxyl groups are present at the first position, second position and third position, it is known as the pyrogallol, which is also chemically known as the benzene 1,2,3-triol. Sometimes it happens that along with the other substituent, hydroxyl groups are present. For example, here you can see along with the hydroxyl group, that is the phenolic hydroxyl group, here there is a presence of the methyl group is present. So here this methyl group, as it is present at the ortho position, this structure is known as the orthocresol. If it is present at the meta position, it is known as the M-cresol, that is the meta. And if this methyl group is present at the para position, it is known as the paracresol. So hydroxyl group along with the methyl group, it is known as the cresol, and depending upon the position of the methyl group, different cresols are named. So these are the various examples of the phenols in which there is a presence of the hydroxyl group that is attached to the aromatic system. Next point that we are going to discuss is acidity of the phenol. As I said, phenols are more acidic as compared to the alcohols, but they are less acidic as compared to the carboxylic acid. Phenols are 1 million times acidic as compared to the alcohols, but still they are regarded as the very weak acidic compounds as compared to the carboxylic acid. So we can say, if we compare the acidity, phenols are lying in between the alcohols and the carboxylic acids. Now the acidity of phenol is due to its ability to lose the hydrogen ion to form a phenoxide ion. Now here in this reaction you can see why phenol is considered as acidic. If we consider this structure, we can divide this structure into 3 parts. One is this aromatic system, then this second part is oxygen, and third part is hydrogen. Now we know what is the meaning of acid. According to Lewis theory, acids are the substances which donate the hydrogen ion. Now here we can see in this structure also, that is the third part that we have discussed, hydrogen ions can be easily donated. This hydrogen can be easily lost because here if we consider the bond between this oxygen atom and this phenol, that is the aromatic system, this bond is quite tight. Also, the bond between oxygen and hydrogen, this is quite weak. So what happens? This hydrogen is easily lost from the oxygen atom, due to which phenols are easily converted into phenoxide ion and the hydrogen ion. And as you see here, as this phenol donates the H plus ions, they are considered as the acidic compounds. Means acidity of phenol is due to its ability to lose the hydrogen ion and to form the phenoxide ion. Also, why the bond between this aromatic system and oxygen is quite strong? Because we know that this oxygen atom is having the electron donating resonance effect. In previous lectures we have discussed about the what is the meaning of electronic effects, inductive effect and the resonating effect. So here this hydroxyl group, that is the phenolic hydroxyl group, when it is directly attached to the aromatic system, it shows the electron donating resonance effect, and due to which what happens, the oxygen atom that is present over here, it donates its electron to the aromatic system, and due to which the bond between the oxygen and this aromatic system becomes strong. So because the hydrogen atom is having the positive charge, so as the electrons of oxygen, they are donated to the aromatic system, net electrons that are present on the oxygen, they becomes less, and due to which ability of oxygen to form a strong bond with the hydrogen decreases, and due to which it is easily lost, it is easily donated to the neighboring element, and due to which it will be converted into the phenoxide ion. And this is the reason why the phenols are acidic, while in case of the aliphatic alcohols, the bond between, as they are not involved in the electron donating resonance effect, the bond between oxygen and hydrogen is quite strong, and in that case hydrogen is not lost, and that's why alcohols are not acting as acidic compounds. Further, next point in acidity of phenol is negative charge is spread through the benzene ring, due to which it is stable. Means whatever the phenoxide ions are there, in phenoxide ion we know that there is a presence of the negative charge on the oxygen, and this negative charge is spread through the benzene ring, due to which phenoxide ions are very stable. Now if we compare the example of phenol, that is the pKa. pKa means what? It's a dissociation constant for the particular compound. Now here dissociation constant of this phenol is 10, and for cyclohexanol is a your aliphatic alcohol, where cyclohexane, which is consisting of hydroxyl group, is about 17. So cyclohexanol is the alcohol and phenol is having the pK of the 10. So thus phenol is 10 raised to 7 times more acidic as compared to the cyclohexanol. So it gives you idea about the acidity of the different compounds. If the pKa is less, we can say that that particular compound is more acidic. So here pK of phenol is 10, so it is more acidic as compared to the cyclohexanol. Now here this diagram gives you idea about the resonance forms of the phenoxide ion. As I said, if this negative charge is spread throughout the benzene ring, that's why it is stable. So here this negative charge is spread through this benzene ring, as this negative ion is donated to this double bond, which this bond is broken down and electrons are transferred to this carbon atom. In such a way, these electrons are transferred to ortho, meta and para position. That's why this particular resonance forms are generated, and that's why phenoxide ion is stable, and due to which phenols are acting as acidic. So this is about the acidity of the phenol. Now you have to give the answer for this question. To give the answer, you have to go to the www.menti.com and you have to use this particular passcode. Also you have to give this similar question. Thank you.